So chapters 10 and 11 give us rotational motion. So now we have things going around in a circle. And so we can describe that. And what we're going to do is we're going to go back to the basic idea. We have a circle here. Okay, it's got some radius r, and you got an object moving here with some velocity v. Now this is some angle theta. Now we know that this distance right here, s, is going to be r theta. We know that v is going to be ds dt. Okay, so that would be equal to r d theta dt. For circular motion, then we're going to assume that r stays constant, otherwise it's not a circle. Well, we're going to make a definition. D theta dt, we're going to call omega. Okay, and so that's not a w, that's an omega. So that means that v equals r omega. Now, the acceleration is dv dt, so that's going to be r d omega dt. And so we're going to make another definition. We're going to say that d omega dt is alpha. So that's going to be r alpha. So we're going to say, what we found was that for x, the derivative of x is v. The derivative of v is a. What we just found was that we've got this relationship that says in a circle, the distance traveled s equals r theta. Okay, the velocity is going to be r omega, and the acceleration is r alpha, where we defined theta as the angle. And then omega was d theta dt, and then alpha was d omega dt. So that makes the second derivative of theta. Okay, just as a is the second derivative of position. So notice these relationships right here are to each other what those relationships are. Okay, so that means that x is the distance traveled, theta is the angle traveled, v is the velocity, so omega is going to be the angular velocity, a is the acceleration, so alpha is going to be the angular acceleration. And then the middle here we have how s, v, and a are related to each other. Okay, well, since x, v, and a all relate to each other in such a way that we have the equation x equals x naught plus v naught t plus 1/2 a t squared. We derived that way back in chapter 2. And v, the derivative of that equation, v equals v naught plus a t. Since theta, omega, and alpha have exactly the same relationships to each other that those first ones do, that means that they're going to have the same equation relationship. So theta equals theta naught plus omega naught t plus 1/2 alpha t squared. And omega is going to equal to omega naught plus alpha t. And so there we have it. Now we have the equations, the kinematic equations for rotational motion. We also have the relationship between linear and rotational motion. And so that's basically it for the first part of this chapter. That's the derivation here. So now we just have to do a few example problems.